Hello everyone, my name is Rizki Maulana and I am first semester informatic engineering student. In this video, I want to explain algorithm and data structure. Algorithm. Informally, an algorithm is nothing but a mention of steps to solve a problem. They are essentially a solution. A data structure is defined as a particular way of storing and organizing data in our devices to use the data efficiently and effectively. Algorithm. In computer terms, an algorithm is a well-defined set of instructions to solve a specific problem. In simple terms, an algorithm is the step to solve a problem or also called a solution. Next, in the algorithm, there is a presentation of the algorithm. The algorithm is expressed in the form 1. Description. Description algorithm presentation use natural language sentence of everyday language. This presentation is suitable for algorithms that are simple and not too complex. Flowchart. Flowchart is a diagram that describes the flow of an algorithm. Flowchart uses graphical symbols to represent the various steps in the algorithm. Pseudocode. Pseudocode is a language that is similar to program code but does not depend on the particular programming language, so it can be used in other programming language. Pseudocode uses keywords and symbols to represent the various steps in the algorithm. Here is an example of a flowchart to calculate the area of rectangle. Description. Calculating the area of a rectangle. 1. Input length value. 2. Input width value. 3. Calculate the area of the rectangle. 4. Display the calculated result. Flowchart. Start, input length and width. Process area equals length times width. Output print area and end. Pseudocode. Calculating the area of a rectangle. Algorithm. Input length, input width, area equals length times width, output area. Qualities of a good algorithm. Input and output should be defined precisely. Input and output should defined precisely. Each step in the algorithm should be clear and unambiguous. Algorithm should be most effective among many different ways to solve a problem. An algorithm should not include computer code. Instead, the algorithm should be written in such a way that it can be used in different programming languages. Each way of presenting an algorithm has its own advantages and disadvantages. Description presentation is easy to understand, but less efficient for complex algorithms. Flowchart presentation is easy for read and understand, but less flexible for complex algorithm. Presentation with pseudocode is flexible for complex algorithm, but less efficient for simple algorithm. The choice of algorithm presentation method must be adjusted to the needs and purpose of the presentation. If the algorithm is intended for lay people, then descriptive presentation is the right choice. If the algorithm is intended for programmers, then flowchart or pseudocode presentation is the right choice. Data structure is a storage that is used to storage and organizes data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. Depending on your equipment and project, it is important to choose the right data structure for your project. For example, if you want to store data sequentially in the memory, then you can go to the RI data structure. Types of data structure: linear data structures, nonlinear data structure. In linear data structures, the elements are arranged in a sequence one after the other. Such elements are arranged in particular order. They are easier to implement. However, when the complexity of the program increases, the linear data structures might not be the best choice because of operational complexities. 1. Array data structure. In an array, elements in memory are arranged in continuous memory. All the elements of array are of the same type, and the type of elements that can be stored in an array. Elements in memory are arranged in continuous memory. All the elements of an array are the same type, and the type of elements that can be stored in the form of array is determined by the programming language. An array with each element represented by an index data 5, 10, 89, 7, 9. For index 0 for 5, 1 for 10, 2 for 89, 3 for 7, 4 for 9. Stack data structure. In stack data structure, elements are stored in the leave party principle. That is, the last element stored in a stack will be removed first. It works just like a pile of plates, where that last plate kept on the pile will be removed first. In a stack, operation can be performed only from one end. Leave principle of stack. In programming terms, putting an item on the top of the stack is called pass, and removing an item is called pop. In the above image, although items 3 was kept last, it was removed first. This is exactly how the leave last in first out principle works. Basic operation of stack. There are some basic operations that allow us to perform different actions and of stack. Push an element to the top of a stack. Pop. Remove an element from the top of a stack. Is empty. Check if the stack is empty. Is full. Check if the stack is full. Pick. Get the value of the top element without removing it. Working of data structure. The operations work as follows. A pointer called top is used to keep track on the top element in the stack. When analyzing the stack, we set its value to -1 so that we can check if the stack in empty becoming top equals -1. On reducing an element, we increase the value of the top and patch the new element in the positions pointed to by top. On popping an element, we are return the element pointed to by top and reduce its value. Before pushing, we check if the stack is already full. Before popping, we check if the stack is already empty. Stack time complexity. For the array-based implementation of a stack, the pass and pop operation take constant time, which is O1. Application of stack data structure. Although stack is a simple data structure to implement, it is very powerful. The most common use of a stack are to replace a word. Put all the letters in a stack and pop out. Because of the leaf order of stack, you will get the letters in the reference order. In compilers use the stack to calculate the value of expressing like 2 plus 4 divide 4 times 7 minus 9 by converting the expression to prefix or postfix form. In a browser, the back button in a browser saves all the URLs you have visited previously in a stack. Each time you visit a new page, it is added on top of the stack. When you press the back button, the current URL is removed from the stack and the previous URL is accessed. 3. Queue data structure. Unlike stack, the queue data structure works in the vivo typical, where first element stored in the queue will be removed first. It works just like a queue of the people in the ticket counter, where your first person on the queue will get the ticket first. In a queue, addition and removal are performed from separate ends. Basic operation of queue. A queue is an object and abstract data structures agency that allows the following operations. Enqueue, add an element to the end of the queue. Dequeue, remove an element from the front of the queue. Is empty, check if the queue is empty. Is full, check if the queue is full. P, get the value of the front of the queue without removing it. Working of queue. 2 pointers, front and rear. Front, track the first element of the queue. Rear, track the last element of the queue. Initially set value of front and rear to -1. Enqueue operation. Check if the queue is full. For the first element, set the value of front to 0. Increase the rear index by 1. Add the new element in the position pointed to by rear. Dequeue operation. Check if the queue is empty. Return the value pointed to by front. Increase the front index by 1. For the last element, reset the values of front and rear to -1. Limitation of queue. After a bit of enqueuing and dequeuing, the size of the queue has been reduced, and we can only add indexes 0 and 1 only when the queue is reset, when all the elements have been dequeued. After rear reaches the last index, if we can store excess element in the empty space 0 and 1, we can make use of the empty spaces. This is implemented by a modified queue called the circular queue. Complexity analysis. The complexity of enqueue and dequeue operation in a queue using an array is O1. If you use pop-n in Python code, then the complexity might be On, depending on the position of the item to be popped. Application using queue. CPU scheduling scheduling. When data is transferred asynchronously between two processes, the queue is used synchronization. For example, I/O buffers, bypass, file I/O, handling of interrupts in real-time system. Call center phone system use queue to hold people, calling them in order. For linked list data structure. In linked list data structure, data elements are connected through a series of nodes, and each node contains the data items and address to the next node. A linked list had 1 next, 2 next, 3 next. Now, you have to start somewhere. So we give the address of the first node a special name called head. Also, the last node in the linked list can be identified because it is next process points to node. Linked list can be of multiple types, singly, doubly, and quadruple linked list. The benefits. The power of chain list comes from the ability to break the chains and put in together again. For example, if you want to put element 4 between 1 and 1, 1 and 2, the steps are 1. Create a new structures node and collect memory to it. And 2. Add its data value as 4. 3. Navigate the next pointer to the struct node the contents to ask the data value. 4. Change the next pointer from 1 to the node we just created. Doing the same to an array will require sitting in the position of all the subsequent elements. Linked list utility. Lists are one of the most popular and efficient data structure, with implementation in various programming languages like C, C++, Python, Java, and C++. Apart from that, linked lists are a great way to learn how pointers work. By practicing how to manipulate like this, you can prepare yourself to learn more advanced data structure like graph and trees. Linked list complexity, time complexity, worst case average, search, worst average on, average case on, insert O1, and average case O1. Deletion, worst case O1, average case O1. Space complexity on. Linked list applications, dynamic memory allocation, implemented in stack and queue in under functionality of softwares, hash tables and graph. Linked list operation, traversal, access each element of the linked list. Insertion, adds a new element to the linked list. Deletion, removes the existing elements. Search, find the node in the linked list. Sort the nodes of the linked list. Things to remember about linked list. Head points to the first node of the linked list and the pointer of the last node is null. So in the next correct node is null, we have researched the end of the linked list. In all of examples, we will assume the linked list has 3 nodes, 1, 2, 3, with node structure. Traverse a linked list. Displaying the contents of a linked list is very simple. We keep moving the temp node to the next one and display its contents. When temp is null, we know that we have researched and the end of the linked list, so we get out of the while. 1. Insert at the beginning. Allocate memory for new node. 2. Store data. 3. Change next of new node to point to head. 4. Change head to point to recently created node. 2. Insert at the end. Allocate memory for new node. 2. Store data. 3. Traverse to last node. 4. Change next of last node to recently created node. 3. Insert in the middle. Allocate memory and store data for new node. Traverse the node just before the create position of new node. Change next pointers to include new node between. 1. Deleting from beginning. Point 1. Point head to the second node. 2. Deleting from end. Traverse to second last element to change its next pointer to node. 3. Delete from middle. Traverse to element before the element to be deleted. Change next pointer to exclude the node from the chain. Non-linear data structure. Unlike linear data structure, elements in non-linear data structure are not in any sequence. Instead, they are arranged in a hierarchy manner where all elements will be connected to one or more elements. Nonlinear data structures are further divided into graph and tree-based data structure. Graph data structure. In a graph data structure, each node is called vertex, and each vertex is connected to other vertical through edges. Graph data structure example: A, B, J, C, D, E, F, G. Trees data structure is similar to graph. Is tree also correction for vertices and edges. However, in the tree data structure, there can only be one edge between two vertices. Thank you for listening. I hope what I have said can be useful for all of us.